Hello, I'm Dan. I like the program. Let's get into this week's problem. Given an integer x, return true if x is a palindrome integer. An integer is a palindrome when it reads the same backwards as forwards. For example, we have example 1 and 2 right here, 121 and 1331. These should return true because 121, same forward as backwards, and 1331 is also the same forwards as backwards. An example is 3 and 4, 7470 will return false because it is not. And this is actually a special case because there's a 0 on the end. If there's a 0 on the end, it'll always return false. And then negative 121 is also false, and this is also a special case because a negative will never have a negative on the other side to reverse itself. So these will return false, and if there wasn't a negative sign on the 121, it would return true, but the negative sign just ruins the day. Let's get into the code. Welcome to IntelliJ. As you can see, I've already gotten started. We have the class palindrome number, we have the method is palindrome, and then we have the main method, which has 3 true cases and 3 false cases. These will all be tested with the system.out.print statements right here. And let's get into the problem. So we're going to start out with the special cases. So I'm going to do a little comment right here so we can demonstrate what they are. So if x is less than 0, then that automatically means that x is not a palindrome, since there will be no negative on the opposite. Let me move this down a line. On the opposite side to reverse. And that was shown in our example at the beginning. Feel free to go back and take a look at it. And then the second special case we have here will be if the first digit of x is equal to 0, then x must be 0. Not 0. Then x must be false. Then is palindrome must return false. My bad. False. Since there will also never be a 0 on the other side to reverse. Now I'll enter here and here. So we'll get started by coding out the special cases. So it's pretty simple. If x is less than 0, or how do we get the first digit of a number? We use modulo. Or if x modulo 10 is equal to 0, and another special case would be if x was just 0, and if x was just 0, if you reverse 0, it's still 0, so it would be a palindrome. So that means we also have to say and x is not equal to 0. We have to enclose this set in parentheses as well. Then, return false. And that's just telling us it wants to consolidate that. And then the next thing we'll do is create a little placeholder called int reverted number. Set it equal to 0, and we'll go into a little scratch pad so I can show you a little more about the interworkings of this program. So we're here on my iPad, and we have this example. And this example is test num a palindrome number. int testnum is equal to 1457541. And we'll say, yes, this is indeed a palindrome number. When you reverse it, it's the same backwards as it is forwards. But why is this? How are we going to convey this to the computer? Well, we have the number right here, 1457541. Swear that's 5. So if we have this number right here, and then we take each individual number, starting right here on the right, we place it right here, and we'll take this one, place it right here, and we'll take this one, place it right here. And then since this is a number with an odd amount of digits, it has 1, 2, 3, 4, 5, 6, 7. We're going to go halfway, and then we're going to add 1, and then we're going to go halfway plus 1. So we're also going to take the 7, and we're going to reverse that as well. And then if we take the remaining 3 digits, which I'll put here in green, 1, 4, 5, we'll see that these 3 match perfectly. And then we can actually disregard this one because it's the middle digit, and if we reverse that, it's still the middle digit, it's still 7. We don't need to worry about it. So to do this, we're going to use a loop, and we're going to store the inverted number inside a variable that we just recently made called int inverted number. Oops, I spelled number wrong. And we'll set that equal to 0, just like we did in the code. And then I'm going to set up a little table right here. We'll have the inverted number right here. And then we'll have x right here. And then we'll have loop 1 in this row, loop 2 in this row, boop, loop 3 in this row, and loop 4 in this row. 1, 2, 3, 4. And so when we go through the loop, in the first loop, we'll want to make inverted number the first number. So inverted number is going to be 1, and then we're going to subtract this first number from the original number in x, and so we're going to get rid of it. We'll cross it out. Now x becomes 1457554. And then we'll do that again. We'll take this 4 right here. We'll add on. It'll be 1, 4 now. 14 essentially. And then we go here. We'll say x. We now want x to be 14575. Then we'll do the same thing. We've got 5, 145, 1457. Since this is an odd number, we go one more time. Grab the 7, 1457, 145. And now we end up right here, where this number is the same as this number. Then we can disregard that extra number, which is the middle number. And then we find out that inverted number will be equal to x, and at the end of our code, we'll return true. So for our loop, we'll use a while loop. And what are the conditions for this loop? Well, if we look over here, inverted number is less than x, less than x, less than x. But when we get to this final value, inverted number is actually greater than x. Now, if this 7 didn't exist, they would be equal. So we want this loop to end when inverted number is greater than or equal to x, right? And so inside this while loop, we'll say while x is greater than inverted number, we'll do all this special stuff in here. And then all that special stuff will be grabbing the first digit every time, and then every loop we'll shift over the first digit, add the first digit of x again, and then we'll shift over again, and then add the first digit of x again. And then for x, we'll be just getting rid of this last digit until we finally have two final numbers. So let's get back into the code. So we're back here in IntelliJ, and now we want to start our while loop. We have our reverted number right here, which is going to keep track of our reverted number, and we're going to make our while loop right here. We're going to say, just like we did in the scratchpad, while x is greater than reverted number. And what are we going to do? We're going to essentially take the first digit of x every time and insert it into a reverted number. And then we're going to take the first digit of x and we're going to chop it off of x. So to do this, we're going to say, we're going to say reverted number is equal to x modulo 10. And then we're also going to say x divide equals 10. And so every time we go through this loop, reverted number is equal to the x modulo 10, and x will have its first digit chopped off. But this will set a new number for reverted number every time. It will get the first digit, but it'll reset reverted number every time. So what we're also going to do to shift the previous number over each time, we're going to say reverted number times 10 plus x modulo 10. So just like we're doing with x, how we're shifting it over to the right by dividing, we're multiplying by 10 and we're essentially shifting the number over to the left. This is done, and that's most of it. And now we're getting to the return statement, and we're going to say return if x is equal to reverted number. And what if the reverted number has the extra digit? What if it's an odd amount of digits in the number? Then we're going to say or x is equal to reverted number divided by 10, and I'll just chop off the extra digit and everything should be good to go. Let's give it a run. We'll run the main method and we should see that it is true, 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 and it is false, false, false. All of these test cases are true and all of these test cases are false. And if you want further proof, this is test num 1, test num 2, 3, this is 4, 5, and 6. So I hope that helped. If it did, leave a like. If you have a better solution, be sure to comment down below. If you have a question, comment down below. And if you really liked it, why not subscribe? Well, have a great day and see you next week.